Hi, in this video I'm going to show you another example on how to find the domain and range of a function. In this case, we'll look at a function which is a linear function. So f of x is equal to 2x minus 3. Let's start with the domain of the function. I always use this idea whenever I look for the domain of a function. I simply answer the question, can I put any x such that x is a real number on the function? And here we have 2x minus 3. I know that if I put a number on the x, then a new number will come out. So any number can be placed on the x. Therefore, the domain is a set of real numbers. Or we can write that as x such that, okay, so the line there says such that x is an element of the set of real numbers. In other forms, you can just say all real numbers. Another form would be from negative infinity to positive infinity. All mean the same thing. Okay? I just answered the question, can I put any x or any number to this x in such a way that the function will have a value? And my answer is yes, I can put any number there. 2 times something minus 3 will become a number. So that means all real numbers can be used. Okay. Now for the case of the range, when the domain is a set of real numbers, it does not necessarily mean that the range will be also the set of real numbers. Maybe for some functions that is true, but for other functions that is not true. Okay. Unlike the domain, the range is not too obvious. So my way of finding the range of a function is to identify the graph of the function. In this case, f of x is equal to 2x minus 3. It's a linear function, therefore the graph of this function is a line. So what I can do is to graph the function, and from the graph I'll be able to get the range of the function. So to graph the function, one of the best ways to graph a linear function is to get 2 points. Okay, so select x and select y. So suppose I set x to be 0. So I'll be setting x to be 0, and later on, suppose I'll be setting y equal to 0. Now look at what will happen. By the way, the y here is your f of x. So if f of x is equal to 2x minus 3, whenever x is equal to 0, that means 2 times 0 minus 3 is equal to negative 3. So the y value for x equal to 0 is 0, negative 3. Is negative 3 rather. So the point is 0, negative 3. Now when I make y, which is the f of x, as 0, so I have 0 is equal to 2x minus 3. If I will compute for x, I'll end up with 3 over 2 or 1.5. So this is 1.5. So if I graph the function, I should be crossing the 2 points 0, negative 3 and 1.50. If you are familiar with this, these points are actually the x and y intercepts. It is where the graph will cross the x-axis and the y-axis. So the graph will cross the y-axis at negative 3, so negative 3, and the x-intercept will be at 1.5. So provided that this is 3, so 1.5 is in between 0 and 3. So I have the y-intercept at negative 3, the x-intercept at 1.5. Connecting the 2 points will give me an estimate of the graph, which is a line. Okay, so how will this help us find the range of the function? So as you can see, the range will be the set of y values that can represent or are represented in the graph. But if you try to look at it, all the y's will have a corresponding value on the graph. And therefore, all the y will be part of the range. Hence, the range will be the set of real numbers. So we can now conclude that the range of this function, so range, is also the set of real numbers. It's any y such that y is an element of the set of real numbers. Or you can just say all real numbers, all real numbers, or you can also say from negative infinity to positive infinity. Okay, I would like to end this explanation by understanding how to get the domain and range of a linear function in general. Obviously, f of x equals 2x minus 3 is just one of those linear functions. But if you are familiar with the idea of the linear function, as we have already mentioned in the explanation, the linear functions can have three possible graphs. It's either the graph is going this way, when we have y equals mx plus p, and m is a negative number. So you can look at it as if the graph is decreasing. Now when m is greater than 0, it goes this way. But when m is equal to 0, it's a horizontal line. Notice we did not include the vertical line because a vertical line is not a function. Okay, or it doesn't satisfy the concept of a function. Okay, it's not a function. So if we have, okay, case number 1 and case number 2, we could say that all y's can be obtained. All the numbers in the set of real numbers are part of the range because it will cover all the way up and all the way down. In the same way, in the second, when m is greater than 0, meaning the slope is greater than 0, it's positive. You can still cover all the y value. So all the y value will have a corresponding x value. And then, so same with number 1. Okay, so all the y's can be mapped on the graph. Okay. For the case of the horizontal line, if, for example, we make an exact, say, function, this is x-axis and this is y-axis, and say the graph passes through the y equals 3. Now, anywhere in the graph, there's only one y value that is being satisfied. Okay, like if I pick the 4 will never be mapped to the graph. Okay, there is no x value whose y value is 4. And the only number that is part of this function, the only y value that will be coming from the function, is just y equals 3. So the range is just the value 3. It is where the graph passes through the y-axis. Okay? So what I'm trying to say here is that if you are given any linear function, if it is either case 1 or case 2, y equals mx plus b, positive or negative slope, the domain actually is all the real numbers and the range is also all real numbers. But for the case of number 3, the domain is actually all real numbers as all x can be mapped on the graph. Say pick an x here, it will have a corresponding value y, which is basically 3 in this example. So all y can be used in the function. So the domain is a set of real numbers. For the range, it is just the value where the graph passes through the y-axis. Okay, so let's end with some examples, quick examples, just to summarize the idea. So let's say, so example, the function is equal to negative 4x plus 5. it's a linear function. Domain will be the set of real numbers. The range will be y, so that y is a real number because it's a linear function. If f of x is equal to 5, domain is still all the real numbers, but the range will be just the y value, which is 5. Okay? So I hope you already know how to get the domain and range of the function. Earlier we showed it by inspection. It's very easy to see what the domain is by simply analyzing it, like, can I put all the numbers here? If yes is the answer, then it's a set of real numbers. And the second way is to visualize it. It's a linear function, so the graph should be a line, and there are only three possible graphs for this line. It's either it's decreasing, it's increasing, or it's a horizontal line. Case number 1 and 2, it will be all real numbers. Case number 3, domain is a set of all real numbers, but the range is where the graph passes through the y-axis. Okay, so I hope that helps you in understanding the concept of domain and range. This is just one of the functions that you will encounter, so there might be some different approaches when the function will change, but basically the idea will revolve around this. Okay, that's it.